Hi. We can also talk about input and output device software, which some examples of input devices are the keyboard, mouse, scanner, microphone, and digital camera and so on. And some examples of output device are video displays, printers, speakers, and others. Now let's talk computer software. If a computer is to function, software is not optional. Everything that a computer does, from the time you turn the power switch on until you shut the system down, is under the control of software. There are two general categories of software: system software and application software. Most computer programs clearly fit into one of these two categories. Let's take a closer look at each. System software. The programs that control and manage the basic operations of a computer are generally referred to as system software. System software typically includes the following types of programs. 1. Operating systems. An operating system is the most fundamental set of programs on a computer. The operating system controls the internal operations of the computer's hardware, manages all of the devices connected to the computer, allows data to be saved to and retrieved from storage devices, and allows other programs to run on the computer. For examples, Windows, Mac OS, Linux 2. Utility programs. A utility program performs a specialized task that enhances the computer's operation or safeguards data. Examples of utility programs are virus scanners, file compression programs, and data backup programs. Point 3. Software development tools are the programs that programmers use to create, modify, and test software. Assemblers, compilers, and interpreters. Application software. Programs that make a computer useful for everyday tasks are known as application software. These are the programs that people normally spend most of their time running on their computers. The commonly used application softwares are Microsoft Word, a word processing program, and Adobe Photoshop, an image editing program. Some other examples of application software are spreadsheet programs, email programs, web browsers, and game programs. At the most fundamental level, computers do not understand words, images, or videos. They only understand two states, on and off or zeros and 1 foot. A computer's memory is divided into tiny storage locations known as bytes. 1 byte is only enough memory to store a letter of the alphabet, or a small number. In order to do anything meaningful, a computer has to have lots of bytes. Most computers today have millions, or even billions, of bytes of memory. Each byte is divided into 8 smaller storage locations known as bits. The term bit stands for binary digit. To and me, this is only a series of zeros and ones. To a CPU, however, this is an instruction to perform an operation. Point 1. It is written in zeros and ones because CPUs only understand instructions that are written in machine language, and machine language instructions always have an underlying binary structure. A machine language instruction exists for each operation that a CPU is capable of performing. Computers can only execute programs that are written in machine language. As previously mentioned, a program can have thousands or even millions of binary instructions, and writing such a program would be very tedious and time-consuming. Programming in machine language would also be very difficult because putting a 0 or a 1 in the wrong place will cause an error. Although a computer's CPU only understands machine language, it is impractical for people to write programs in machine language. For this reason, assembly language was created in the early days of computing as an alternative to machine language. Instead of using binary numbers for instructions, assembly language uses short words that are known as mnemonics. Assembly language programs cannot be executed by the CPU, however. The CPU only understands machine language, so a special program known as an assembler is used to translate an assembly language program to a machine language program. High-level languages. Although assembly language makes it unnecessary to write binary machine language instructions, it is not without difficulties. Assembly language is primarily a direct substitute for machine language, and like machine language, it requires that you know a lot about the CPU. Assembly language also requires that you write a large number of instructions for even the simplest program. Because assembly language is so close in nature to machine language, it is referred to as a low-level language.